Now we have dealt with right angle triangles, we also want to be able to deal with non-right angle triangles. So here we have the cosine rule. So this is one of two rules we can use to find sides and angles in non-right angle triangles. So there's two forms this comes in. This is when I'm trying to find a side length, the first one. The second one is when I'm trying to find an angle. So both these forms are on your cheat sheet, but they're just rearranged versions of each other. Key thing with non-right angle triangles is the labeling, just like with the right angle triangles. So we label them A, B, and C. Our angles are capital letters, and our sides are the same letter but lowercase when it's opposite. So little a is opposite big B, little b is opposite big C, little c is opposite big C. That labeling is important. I also suggest that you label the unknown as A. So whether it's little a or big A, I don't care, but it will make your life easier. We also can call this an SSSA triangle because we need 3 sides and an angle in order to use this rule. One of those is unknown, but we either need 3 sides and an angle, one of them unknown. So here are my examples. So I'm going to start by labeling my unknown as little a, which makes the angle opposite at capital A. And then for the cosine rule, it doesn't matter which way you put B and C. So my rule is a squared equals b squared plus c squared minus 2bc cos a. And all I'm going to do is sub my information into that equation. So it is a lot of writing. So my next suggestion is actually to solve this. So to make it into an actual number. Because that means there's less to work with because we just have one number going on. Okay, so we get to x squared equals 94.829. While I only write 3 numbers, I'm going to keep calculating using all of the numbers so that I get it accurate. So then I want to find what x is, so that's going to be the square root of that answer, which is 9.7 centimeters. And so while it's a lot of writing, it's not actually that hard to use the rule. You just sub in, solve, and then do your last rearrange. So up here I'm trying to find an angle. So capital A, little a, B and C don't matter. So cos A equals B squared plus C squared minus A squared over 2BC. So I'm just going to sub my information into this one. So 9 squared plus 8 squared minus 11 squared over 298. So once again, I'm going to solve this side so that I get cos theta equals a number. So 9 squared plus 8 squared minus 11 squared divided by 2 times 9 times 8, which is 0.1667. So then to get that cos by itself, to get that theta by itself, I need to rcos both sides, which is going to get me as my angle 80.4 degrees. And that's how easy it is to use the rule. So that's the cosine rule. There's another rule which is the sine rule. So this version, the length form, is on your cheat sheet. This one is not, okay? But all you got to do is remember is to flip it. If you just flip it over, you can then use the angle form. And for the sine rule, it's AASS. We need 2 angles, 2 sides, one of them unknown. And we label the triangle the same way. So using it, here we go. So little a, capital A, little b, capital B. Now our equation looks confusing because there's 2 equals in it. But really, we're just going to use two of the fractions, so we can just scrap that bit. So we're going to use a on sine A equals b on sine B. And that's all we're going to use. We're just going to scrap that c bit. So I'm going to sub in my values. Equals b on sine B. Once again, I suggest finding that number on your right hand side so that you have less to deal with. So we get 5.19. So then my last step, I'm going to times both sides by sine 82, which is going to get me x equals 5.19, so my answer, times sine of 82, which is 5.14. And that is my missing length. Alright, so that's finding a side length using sine. The other version is to find an angle. So a, little a, b, little b. So remember, if I'm finding an angle, I just flip my equation over. Alright, so now I sub in my values. Oh, that's not an A, that's a 6.9. Over 6.6. Okay, so now sine theta equals 6.9, and I'm going to figure out what that number is. 37 divided by 6.6. So that's 0.0911. Then I'm going to times both sides by 6.9. So I'm getting closer to an answer, which is 0.629. Then the last step, I'm going to arc sine that number, 0.629, to get what my angle is. So my angle comes out at 38.99 degrees. So we could really call that 39 degrees. Cool. And that's how we use the sine and cosine. Once again, I've got a worksheet for that one, I think, because I don't like the questions in the book.